That's for getting their domain and their host. I mean, most people manage to do it without any problem. And there's only 1 week left, so I'm a bit worried. Yeah? Also, this activity 2 is really essential, because you cannot complete activity 4 without having done activity 2. You cannot complete activity 5 without having done activity 2, and many others rely on activity 2. So if you don't have a domain and a host, you really have to hurry up. Okay? Activity 3, a bit better, but still not very impressive. And now if we look at activity 4, it's pretty dreadful. Okay? The first week I had 141 students who submitted the activity. Now we are at 54. I mean, it's not really serious. Okay? So next week we have enhancement week. So we will not have any class. Next time, I will ask you to leave the room. Okay? You need to respect people. So hopefully enhancement week will be allowing you to catch up. Okay? But it's not a good start for the whole class. Also, out of these 54, I've contacted 17 of you, asking you to resubmit because the quality was not good enough. Okay? So I appreciate the efforts, and that's part of the rules of the game. Okay? For the first week, if it's not all working well, that's fine. I will give you some feedback, but 17 have to resubmit. Okay? So I'm going to give you the feedback just right now. Okay? So people emailed me asking me where is the feedback. The feedback is now. Okay? So only 1 week left for activity 2. Yeah? I mean, you can see that the rhythm is quite intense. We have 1 activity a week. The set of activities will count as 80% of your final mark. So, you know, if you don't do your activity weekly, you are going to fail the module. Okay, so here are some comments I got from you. So apparently some people were a bit anxious about HTML. They gave it a go and everything went well. Congratulations. Some people found it difficult, but still managed to do it. That's great. That means you are learning, getting new skills. Some people took advantage of their mentors, and they said that the Facebook group is working well. Who has been using their mentors this week? If you don't have a mentor, send me an email and I will allocate one to you. Nobody has used the mentors. Just one person. Okay? So, you know, they are well paid to help you. So take advantage. Yeah, and other comments which were quite positive. Some general questions I got. Are we going to use WordPress again? And the answer is yes. Okay. So don't delete your blog. Hopefully you are using it, but we will need it for other activities. So some people were quite happy about the website they have created, with reason. And they say, okay, what are girls? That's the last time, okay? So what is the limitations? We have learned HTML, CSS, we can already do some interesting websites. What else can be added? Why do we need to know more? So you have created a great website, but it's a static website, okay? So if you do not edit yourself your website regularly, the content is not going to change. There is no possibility of interaction, so the user can only passively look at your website, possibly play a video, but nothing else. and your website is not connected to any database. So we have 4 more lectures and activities on web prototyping. So during those 4 weeks, you will learn some of the things you can add to your website. Okay. So now some feedback about the submission I got. So something very common has been for people to give me a link to their hard drive. Okay, my website is on D/. It made me smile as well, I should say. Okay, so obviously there is no way I can check if it's good, or maybe you give me your laptop for Christmas. So no, it's not good enough. Okay, so the activity this week was not only to learn some technical skills. I know it's snowing, but you know the kids, 4 years old, when there's a bit of snow, they get all excited in the rooms. Okay, so yeah, so the activity was not only to get the HTML and CSS, the technical skills, but was also to upload the material on your host so that you can share the material not only with myself, but with the international community. Okay, so if you want to get your 4%, your material has to be live online. Okay. So some other people put stuff on Dropbox and so on. I'm not interested in Dropbox. Okay. I'm not interested in downloading your file and running them. I want to accept to get on your website. Okay. So people who didn't do that, they got an email from me, and please upload that in your domain. What else? Yeah, other people who didn't want to do the job who gave just me screenshots. So, as I said, I'm not interested to know the structure of your hard disk. You need to get a domain and a host. If you haven't done it yet, go for it. Okay. Otherwise, you are not. It's likely you will not pass the module because there are so many activities which rely on you having a domain, a host, that you will not manage to complete the module. Okay. So it's essential for this course. And also you need to learn how to upload data. I think some people had these issues. They had the domain, they had the website on their personal computer, but the link between the two was missing. Okay. So if you are not sure about this, please contact your mentors. They are experts and they will be able to show you that very quickly. What else? Some people, especially people who have interesting names, like myself, need special characters, okay? Characters which are not in the standard British keyboard. And you want to have that on your web page. I mean, if you want to write your name and stuff, how do you write in HTML some strange characters? So if you do a bit of research, you can see that many characters and symbols can be used in HTML. So for example, for the copyright symbol, it's just this letter followed by the word copy. And automatically HTML will understand what it means and display the copyright symbol. Okay? Some people ask me if they could expand their websites and do more than what I've been asking, and the answer is yes. Okay. Of course, that's what is behind the philosophy of IT Toolbox. We are giving you the tools, we're giving you some activities, but that's just the basis for you to jump and go for it. Okay? You have spent a bit of money, you have learned some technical skills, so now use your website. Okay? So, can you sell things? If it's legal, yes. If you are not losing money in the process, I mean, you know, being a business person is not that easy, but if you feel like doing it, go for it, okay? So it's highly recommended to expand it, your website, and I should remind you that 20% of the final mark of the module will be the creation of a website with different complex features, and that will count as 20%. That will be expected at the end of the year. Okay? So everything we are doing on the website now is accumulating, and then when you have to provide a full functioning website with advanced features, you will already have done quite a bit. Okay? Okay, so that's another one which made me smile a lot. So a lot of people couldn't access one of my CSS style sheets, okay, and they were really blocked, you know. I press the link and the computer is saying no, and there's no way I can get the data. Anybody managed to get the data? What was the problem? I mean, I will show you how horrible it was for those people. I'm sure nobody in the room would have made such an easy mistake. Okay, so if I go on IT Toolbox, information, activity 4. So I had this link for the first style sheet, and everybody got it. And then they tried the second one, and they say, oh, it's all broken. You know, no way I can access this style sheet. Yeah? So that's what my mom would do as well. Okay? She would click and it's not working, it's broken. Let's call a technician. So you are supposed to become IT professional, okay? So you maybe can switch on your brain, okay? You look at the path and say, the previous path was finishing with CSS. Now I have a path finishing with CSS bracket. Let's try to remove the bracket. Oh, fantastic. Yeah? So please, yeah? All those people who said, yeah, I couldn't access it. It was impossible. I mean, let's be serious, okay? So not only it's not serious, you know, and also it means that you are very lazy people, okay? Because the path was written here, yeah? If you read this line, you are not going to add the bracket, yeah? So you could type it, and it would work, yeah? So please, I don't want any of these silly emails and complaints, because, you know, doesn't look like I'm working with professionals or future professionals. Okay, so some people had problem with CSS, they recognized it. So please use your mentors or spend more time, because it's really a skill that you need to be able to handle. So some people had problem with linking. So the first task, I think, was to download my files, okay? Not trying to link to my website, which is far away, and also my website may be shut down at any point, okay? But how can you be sure that I will keep those links forever, okay? So first you download the files, you put them in the directory where you have your website, and then you link it. We said that there were two ways of linking during the lecture. Either in the header of your HTML file, you are just providing the path, okay? Where is the CSS file located relatively to where you are, okay? So if the file is in the same place as your HTML file, it's just / the name of your CSS file. If you create a directory in order to put all the CSS file nicely there, you have to add the name of the directory. Okay? An alternative, as I said, was to copy the content of the file in the header. And in that case, you don't have to do any specific linking. But in this case, the best option was to link to the file, because I provide you the file. Yeah. So it's really something you need to master, and if you have problems with that, please go back to your mentors and get some explanations. Some people had asked some very interesting questions, not just silly ones. So there was the idea, the question was, in CSS, how do you get the background of your HTML page red? Okay. And someone found that there were two possible commands, either background red and background color red. Okay. And the person was a bit puzzled. Why are there two commands for doing the same thing? Actually, the full command is the second one, background color red. However, there is a shorthand which allows you not to specify each time the property. Okay, because you have many properties which can be associated to the background. You have a color, you can have some images. These images are quite small, they are repeated in the background, and you can decide how it's repeated, if it's repeated, and where to put it in one corner, and so on. So you have all this information. So either you have each time background, the parameter, semicolon, and you choose the right keyword, or you put everything in one line. Okay? And CSS is going to understand that. So the color is here, the image is here, you don't want to repeat, and where it should be attached and positioned. Okay? And the thing is, you don't have to put everything, but you have to put them in the right order. Therefore, if you just write background red, it's going to understand that red is going to be for your color. Okay? So that's the explanation why these two lines will give you the same result. Okay, so now let's look at some example of your websites. Okay, because some of you did a great job. So we have this one. I chose this one because it was quite a basic website. Okay, it's just following the instruction. It's not doing more, but it's following the instruction. It's doing exactly what it's asked. So that's full marked. Okay. So here is the basic website, and then they provided two other links so that you could see the website with my beautiful CSS. Okay, so this one and the spring one. I'm not sure which one is the most horrible of the two. Okay, but you know, this person has done a perfect assignment, done exactly what I've asked for. Okay, there's a video about HTML, some pictures, some content, and there are links to the CSS. Some other people did, I think, a bit more than just completing the assignment. No. This one, it was the assignment as well, and instead of creating websites, web pages with the different styles, they provided a couple of pictures, and that's fine as well. It's a good way of presenting the work. What about this one? Okay, so that's someone showing off that they can mix the two. That was an optional question, mixing the spring with the wobbly one. So again, a good piece of work. Quite ugly, but That's what I asked for. Then some people added some fancy stuff, which is good, you know. If you can do more than what I'm asking for, that's great. You know, you are learning and you are demonstrating some skills. I think there is a soundtrack as well, but we may not have to listen to it right now. Okay. Someone interested in the Game of Thrones. So here people have taken advantage of the website to do something they are interested in. Okay. For them, it was not just an assignment. It was also an opportunity to share their interests, their hobbies, and so on. Other people. Okay. So some person providing some information about their school, some movies and stuff. So you can see that the content is increasing. Okay, so some people are really taking advantage of their host and using the space, you know, to express themselves, let's say, and share with the community. What else do we have? Okay, so someone interested in Greek history. Likely that the person is Greek, that would be my guess. And someone interested in fast cars, I think. The fast car of the world. Okay. I guess you need to make a bit of money before buying one of them. But great, okay. All the features are there, and you have been enjoying yourself working on one of your passions, so fantastic. So that's just a few examples, but I have tens of examples like that, so I'm hoping that I will get around 200 examples like that soon, okay? But you can see that your colleagues have done it, so if you haven't done it yet, just give it a go, yeah? Okay, so as I said, as resources, obviously you have the slides, you have the video. I have some links to some interesting websites which are very well done in order to learn how to do some basic programming. And obviously there are your mentors who are expecting your emails. Okay, so let's start the new content of this lecture. It's about operating systems. Okay. So who has heard about Moore's law? A handful of people only? Yeah? So it's one of the fundamental laws of computing science. See? And it's really important. So you have heard about Intel, okay, the microprocessor which is in many PCs. So one of the founders of Intel, Gordon Moore, predicted in 1965, guys, I'm getting a bit annoyed by you, I should say. Okay. So if you cannot behave, please go away. So in 65, he made a prediction. Okay. He said, I believe that electronic components are going to get smaller and smaller. And he made a very specific prediction. He said that the number of components you could put is going to double every 18 months. Okay. So that was a prediction in 1965. And nowadays, the rule is still correct. Okay, so that's one of the great predictions of humanity, a rule which has been valid for 50 years. Okay, so indeed, microprocessors are getting smaller and smaller, and that's why your computers are getting more and more powerful all the time. Okay? You wait for 18 months, and it's likely you will have a computer which will be at least twice more powerful than the one you have now. Okay? So if you don't need it now, just wait a little bit. It will be much more powerful for the same price. Okay? Initially, it was fantastic because not only you had the number of transistors, so that this component, the electronic components you could put on a chip, which was doubling all the time, but as well, the speed of your processor was doubling all the time. Okay? So instead of going just twice faster because you have more components, you would go 4 times faster because each component works twice faster. Okay? However, for the last 10 years, the speed of computers have stopped increasing. Okay? So now we are not making any progress on that anymore. And the reason why is because the more speed you have, the more heat you are producing. And now it's impossible to cool them down if you put more speed. Okay? So you don't want your computer to melt, so you cannot increase the speed. And you can see that even some processors have the speed which is going down. Okay? So basically, speed has been an issue. Now we are not making any progress anymore. Are we still going to make progress regarding the number of components you can put on a chip? Okay. So that's the question. That's been valid for 50 years. Can we expect that for the next 50 years? So Intel, so still the same company, predicted a bit more than 10 years ago that around now we will not be able to make transistors smaller and smaller. Okay, there is a limit. If we are back to Gordon Moore, in 2005 he said, you know, there is a limit. At some point we are getting so small and so small, which means that each component should have the size of one atom, which is not possible. Okay? So he knows, and everybody knows, that this law is going to stop at some point, and we don't really know when. So Intel said between 2013 and 18, but it's still going strong. And some theoretical physicists said recently that within 10 years, that will be the end of it. Okay. So within 10 years, no more improvement in computers due to the size of the components. And you may have already seen this new trend that now you are not getting processors with so much more components, you are getting several of them. You are getting multi-core processors. Okay? So you duplicate instead of making smaller. Okay? And obviously, thanks to Moore's law, you can create some very powerful microprocessor with a very small size. So nowadays, you have microprocessors everywhere. Okay? In your car, some people have one in their fridge. I mean, it's becoming incredible. And this people to computer ratio is increasing very fast. You remember this prediction from IBM? There's a world market for 5 computers. It hasn't been as good as Moore's. Okay. But that was the case. So initially, during the 50s, you would have a few world computers. After a few decades, you will have the Kingston University computer. One computer for all the students. Okay? Then we move to the stage of the personal computer, everybody having one own computer. And now we are getting this stage where everybody has more than one computer. Everybody has a smartphone, a laptop, possibly a tablet, a camera. That's already 4 computers you have. and it's likely that you will have an MP3 player or whatever. So some of you have 10 computers. Okay? So you can see that the world has completely changed. So all those computers are controlled by what is called the operating system, or OS. So it's controlling the execution of all the programs which are on your computer. And it's also the interface between the user and the hardware. Okay? As a user of a computer, you don't want to type numbers in hexadecimal or in binary. Yeah? You just want to have a nice interface where you can write in English or click on things. Okay? So you don't want to interact with the hardware. Possibly you want to interact with the operating system. So if you look at how a computer system is organized, at the lower level you have the hardware. Okay? And we had a lecture on that 2 weeks ago. The level which is just above the hardware is the operating system. Okay? So there is interconnection, there is communication between the operating system and the hardware. Then there is the application. So the application is going to communicate generally only with the operating system, not worrying too much about the hardware. Okay? And then you have the user who doesn't want to have to bother with the hardware, doesn't want to bother about the operating system. They just want to learn the application, how to use the software. Okay? And as an IT professional, you are not going to be a user anymore. And you will be working either at the application level or at the operating system level. Okay? And if you work at the application level, you will need to have a good understanding of how the operating system works. Okay? Otherwise, you will be creating applications which will be too slow, too memory greedy, and so on. You will need an understanding of how the operating system works and how it's going to execute the program you will have written. Okay? But some of you may work on the design of operating systems. And in that case, you will need to get a good understanding of the hardware as well. But I guess the majority will be working at the application level. Okay.
Linux.
So what is the most popular operating system?
Linux.
Windows. Nowadays, Windows. Microsoft.
Okay. So I can say that all your answers are wrong. Okay.
IBM?
No. All your answers are wrong simply because the question doesn't make any sense. Okay? It doesn't make sense to ask what is a popular operating system. We need to be a bit more precise than that.
Android?
What is the most popular system on PCs? That's the first question. Windows? So I am giving you the figures of last month. Okay?
Look at that Windows. Look at that.
91% is Windows. Okay? 6% is Mac. 1% is Linux. Okay? So if you have a PC, it's very likely it will be running on Windows. I can give you some trends. Okay? So number 1 is Windows 7. Number 2 is Windows XP. Number 3 is, I think, Windows 8. But we all know that it's rubbish, so most people are not going to update, and they stay with Windows 7 and XP. And very few people are using the Mac OS or Linux. Okay? The trend is not really changing. That's been quite stable. That's very specific systems that very few people are using. Okay? So if you want to target the market of PC programming, you need to keep in mind that most people will be using a PC. Okay? Whatever your religion, if you don't like Microsoft or love Linux or whatever, most people will be using a PC. And the trend hasn't changed in the last few years. Yeah? So, what about mobile phones? What is the most popular? Android? Okay. So according to my figures from last month, 47 Android, 43 iOS. Okay? So let's have a look at the trends. You can see that Apple, guys, you can see that Apple had a very good start. Okay? The iPhone was definitely a revolution, the first smartphone, and they started with 60% of the market. Okay? Google, with Android, decided to fight back. And the trend has been that Android has been increasing. And during the summer, Android has overtaken iOS. Okay? Windows is almost non-existent. Yeah? I mean, it's very important, you know, because when I ask you what is the main operating system, it really depends on which device you are going to use. You know, if you want to be an app developer, forget about Windows.
Linux.
Yeah. No, you need to choose between iOS, which is a form of Linux, or Android. Okay. But according to the trend, it looks that Android is going to continue growing. Okay. So which language will be the most, or operating system will be more popular in 3 years' time? Possibly Android. Or maybe something new is going to appear.
Do they use C++?
Mostly programmed in Java as far as I know.
Yeah, Java is the most common.
Is that for the UK or is it worldwide?
Worldwide.
Okay.
Okay, so now if you have a web server, okay, so again, it's a very interesting market. So you have two main systems. One is Apache, and the other one is the Microsoft one. Okay, you can see that Apache has been dominating for 20 years, and now Microsoft is getting level. Okay. So Apache usually works with Linux. Yeah. Then we have Microsoft, and the third system is also an open source system with a Linux flavor. Okay. So you can see that in the case of web server, there's a mixture. There's no clear domination. If you remember well, when I asked you to get a host, I asked you to get Apache. Okay. I want you to have a bit of Linux experience as well. Okay. At the university, most of the machines are going to be Windows, but I want you to be able to do a bit of Linux as well. Okay. Because you don't know what your career is going to bring you to. Okay. What about supercomputers? Linux.
IBM. Kill you, Charlie.
IBM is not an operating system. Okay, so if you look at the trends for the last 20 years, so initially it was Unix, and then it has switched to Linux, so it's just the son of Unix, really. And Apple has tried and has failed. Windows is trying, but is almost non-existent. Okay. So if you want to work on supercomputer, if you are interested in using the latest computer that the British government is going to use for weather forecast, you need to learn Linux. Okay. So you can see that you cannot get out of uni and apply for a job knowing only one operating system. You need to have some understanding of others, okay? Because depending on your environment and the job you will get, you will need one or another. It's quite a complex view. You don't have one system for everything.
IBM.
So now I have another question. What is the most popular operating system on Mars? Okay. So you can imagine that on Mars there are some constraints. Okay. That if your computer crashes, it's a bit difficult to reset it. Okay. So maybe we'll not use Windows. Is Linux much better?
Yes, of course it is.
Yes.
You wouldn't use Linux on Mars. It's not reliable enough.
Unix.
Resource.
So you need some specialized operating system. So you have the one which is on board of Curiosity is called Integrity. Okay. So you can see that the computer which is on board is not a fantastic machine. Okay. Not as good as what you have in your laptop. But you can imagine that there are very different constraints. Okay. That it needs to be working in real time. Okay. Which means that if something occurs, the rover has to react. Okay. Cannot just wait for some time. It needs to react in a split of a second. Okay. You cannot reset the button. There are also some issues with communication. Okay, it means that when it's on Mars, if where the rover is facing the Earth, communication is possible. If it's on the other side of Mars, you cannot communicate. Okay, so you can see that a lot of the functions can be time critical. So it had a 2-year mission. And the aim was to find evidence of life, and the outcome has been they haven't found life now, but they think that in the past they may have been. Okay, and the system is still running. Okay, it was supposed to go for 2 years. We are already in the 3rd year, so the computer hasn't crashed. So it's a good operating system. So that's a sunset on Mars. Okay, so what is this operating system trying to do? So make the execution of your programs easy. Okay, it needs to be transparent. When you are using a computer, you don't want to worry if it's a Linux, if it's a Windows. You just want to double click on the icon of your application and use it. Okay. Also, you want the operating system to use the hardware in an efficient manner. Okay? It's not just about hiding everything, it's taking advantage of your hardware. Okay? If you have an 8-core processor, it would be very good if your operating system could say, okay, you have 8 cores, let's use the 8 cores and not let's use only one. And if you use the wrong operating system with the wrong settings, you will just use one. And you will have 7 cores doing nothing. Okay? Also, an operating system allows you to share resources. Okay? So you will have an operating system on the server, and several clients will be able to interact with that server at the same time. Okay? And that's the operating system which allows you to do that. Obviously, you want to have your application which can move from one system to another, and the operating system is trying to make you hardware independent. Obviously, you want security. Okay, you don't want to run one application and start deleting everything which is on your computer. So the operating system is trying to keep everything well protected. And obviously you want a system which is reliable. Okay. So on a PC it doesn't matter that much if it does crash, but on Mars it's a really big problem. So we have already looked at the architecture of a PC, and the architecture is pretty much the same in your smartphone. And basically you have all these different components. You have your processing components, you have some disk controller, you are controlling your devices, and you need to share and organize all that. Okay? And the operating system is dealing with that. So an operating system is allocating resources to your programs, is controlling your programs, and also the operating system is a program in itself. Okay, it's always running on your computer. Okay. So imagine that you have a PC with only one CPU, but you want to run several applications. Okay? You want to write your report, at the same time you want to listen to some music and check if some new emails are arriving. Okay? So you would like all that stuff running on your PC. However, if you have only one processor, in principle you have one processor, one application. The solution is to use something which is called multitasking, okay, something that women are very good at, is doing several things at the same time. Okay? So you have a resource and you are going to share it between your different applications. Okay? And that's what the microprocessor, the operating system is going to try to do. Make sure that all your applications are running at the same time in a very seamless manner, so that when you are typing your report, your music doesn't stop. Okay? And that your emails are still coming. So the operating system is trying to organize, making sure that everything seems to be happening at the same time. But you need to remember you have only one CPU, you have only one calculator, so you have one operation at a time. The three things are passing one after the other. So you need to share the time on your processing unit. Okay? So either you have one person using several applications, so all these applications are competing for your processing unit, or you have one processing unit and several users. Okay, so when you are logging in on a server, several people are trying to access the data on this server, and you don't want to be waiting for other people to have finished. You would like everybody to access the data at the same time. So in order to solve this problem, what you need is called a scheduler, okay, in order to manage the resources. So what you want is for this scheduler to be fair. Okay? If you have 10 people trying to access a server, you want everybody to be waiting more or less the same amount of time. Okay? It wouldn't be fair that one person gets a high priority and everybody else is waiting. Also, you want to be clever. You want the system to be able to discriminate between the type of applications. Okay, so for example, in my example, you have one application which is listening to some music, and the other one is checking that new emails are coming. You don't need to check your emails every second. Okay? For us, if we have an alert every minute, it's maybe a very reasonable time. However, you want your music to appear to be continuous. It would be right to wait for 1 minute for getting the next note. Okay? So depending on the application, you are going to treat them slightly differently. And obviously you need to be efficient, try to optimize all those parameters. Okay, so let's look at an example. Here I have 5 applications that I would like to run at the same time. So when I start my computer, I want to run this application. And after a while, I would like to start another one. So here I'm showing you when in time I'm starting the new application and how long this application is going to last. Okay? So one strategy is to say, the first application which is there, I just run it until it does finish. Then I run the second one, then the third one, and so on. So typically that's called a first in, first out scheme. And you run the application one after the other. Okay? So we can notice that, for example, the last application, which was very quick, okay? For running that last application, I need to wait for all the application to finish, okay? Which, in principle, is not what you wanted. You wanted to check something very quickly and then go back to your other applications. So this system is not very good because if you have a short application, you will only you risk to run it only at the end after all the long applications have finished. Okay, so you can see that the yellow application would finish at time 20, whereas it arrived at time 8 and could last only 2 steps. Okay, so it feels that such a system, when you run each application one after the other, is not quite a good system. So another type of scheduling is called the round robin. Okay? So you are going to run an application, and when there is another application starting, then you are going to divide the time, and you are going to split your applications in small chunks. Okay? So you start running application 2, let's say for 1 time step, and you go back to 1. So you are going to alternate between 1 and 2. And then application 3 starts. So you are going to alternate between 1, 2, 3. And then 4, and so on. Okay? Which means that in this case, for example, our short application will be finished at time step 15, while in the previous one it was finishing at time step 20. Okay? So you can imagine that for a long application which takes 2 hours, finishing, imagine we have 2 applications, one of 2 hours, one of 5 seconds. In the first case, you will wait for 2 hours for running your 5 seconds. In the second case, after a very short amount of time, you are going to run your short application. So the long application will last 2 hours and 5 seconds, and your short application will maybe wait 10 seconds, which is a better policy. Another scheme, which is, let's do first what is short. Okay? So you get your application running, and you are going to run the short one, number 5, before number 3 and number 4. Okay? Because the 3 were waiting, and we give the priority to the short one. So it's another strategy. The problem of this strategy is you need to know how long your application is going to last. Okay? In the previous one, every application is chunked in pieces. So if you don't know the time of your application, it doesn't matter. Okay? In this one, where you choose the longest, the shortest first, you need to know what is the shortest. Okay? So if you are running jobs, in this case, imagine you want to run a supercomputer. I mean, the university has a supercomputer, and you say, yeah, I want to run this job. It's going to ask you, how long is it going to last? Say, okay, it's a job for 10 minutes. Oh, it's a short job, so we give you the processing power. After 10 minutes, they shut you down. If you needed 11 minutes, tough. Okay? So you need to know exactly the time you need for your application. Okay? Which is possible in certain circumstances. Also, in that case, a person who has a long job may never get their job running. Okay? every day there's someone who is going to come with a short job, and the person who needed one full day of processing will never get it. Okay? So you can see that there are many strategies, and you need to find a good compromise, and this compromise depends also on the type of applications you are running. Okay? So if we look at Windows XP, okay, so typically Windows has been made for personal computers. Okay, so you have usually one user running many applications. So the objective for a Windows operating system is to have the feeling that you are running in real time. You double click on something and it's running. You don't have to wait. Okay? And also it's about having the impression that everything is working well. Okay? So it's about the perception of the user. And we know that we are only humans. Okay? So maybe an unfair strategy is going to be run, but if we feel that everything is working the way we want it, it's fine. Okay? We just to have the impression that performance is good. So that's what is behind a Windows XP operating system. So in practice, they will use a round robin, and you will have different types of applications with different type of priorities. Okay, you will have high priority tasks, and they will be round robin around those, and they will have lower priority tasks, and there will be a round robin there as well. So real-time processes will have the highest priority. When you touch your keyboard, you will get the priority. You touch the key, it's going to analyze the data. Okay. And once you have started using an application, you are going to start chunking bits. The priority of that application is going to be lowered down, because it says, okay, it may be a certain priority, but it's getting a bit long, this application. So let's lower its priority so that other applications have the opportunity to be run as well. Okay, so it's a compromise between the round robin and the other one, which is shortest application first. And each time you touch your keyboard in one of your applications, priority is going up. Okay? The user is interested in that application. We want the user to perceive good performance. So if the user is touching the keyboard, priority is going up. Okay? So that's a good trick. When you are running several things on Windows and you want one application to go a bit faster, double click in that window. Okay? Because Windows will understand they are interested in that. Let's give them a bit more resources. Okay? So if we go on my machine and we look at the task manager, you are all familiar with the task manager? Yeah? So you can look at the processes which are currently running. So we can see that there are some stuff like win-logon. Okay, so that's part of the kernel. Okay, I logged on my machine. I didn't run that application. It's automatic. It's always running on my machine. Yeah. So if I look, I click the right button. I don't know if you have done that. And you look at the priority. You can see that this process has a high priority. Okay. Automatically, Windows said, okay, logging with Windows is something very important. I need to listen if people want to log out and so on. So that must be at a high priority. On the other hand, I'm running Chrome, and the priority is just normal. Okay, it's not critical. So Windows gives me a normal priority for running my browser. Okay, and for my PowerPoint, it's running Where is my PowerPoint? PowerPoint. Normal priority as well. Okay? So basically, all the applications which has to do with the operating system have high priority, and the one I'm running have average priority. But the thing is, I can change the priority if I want. Okay? If I'm running, let's say I have a big job. Let's imagine you are doing some image processing with Photoshop. You know, some applications takes forever. Yeah. So if you try to do some complex image processing, you have a big image, you click, and you wait for 10 minutes. Yeah. So what you can do is, before clicking, give your Photoshop a low priority. So it's not going to freeze the whole machine. It's going to work at a slow pace. Okay? So instead of 10 minutes, maybe we'll need 20 minutes. But during that time, your machine will be alive, and you will be able to surf the net, check your emails, and write a report. Okay? So an advanced user of Windows is playing with priorities. Okay? Obviously, you need to play it well, because you can, in the worst case scenario, you crash. Okay? It's not a big deal. But if you lower too much the priority of the operating system, your system is not going to be responsive, and you may crash. Okay? But I would recommend experimenting a little bit. Okay? Try to see what it changed to higher a priority of one application and lower another one. Okay? Okay, so now we mentioned Linux. Okay? So we have seen that Linux is not used so much on people with PCs. It's used a lot on massive computers and on servers. Okay? And so it means that there are machines that usually are shared between people. Okay?
More functional.
It's a different type of machine, you know. You have a supercomputer and several people want to use it. So it's not a desktop computer where you are the only user with many applications. Now you have several applications, but you have many users as well. Okay? Which means that the objective is still to be responsive, to try to be real time, but now you want to be fair. Okay? It's not anymore about the user experience, make people happy. It's about being fair. If 10 students trying to access the same supercomputer, each student should get the same amount of time. Otherwise, it's not fair. Okay? So you can see that the emphasis is different from a Windows. Okay? And depending on what you are doing with your computer, one system may be better than another. So again, they are using round robin for the processes which have of high priority, and then they are using FIFO, so first in, first out, for the other processes. Okay. Obviously, they are using also a system of credits, which means that the more time your processing lasts, the lower priority is going to get. Okay? So it's a different way of finding a compromise between large, short processes which should be going first and trying to be fair. Okay? So another thing which is very important about operating system is security. Okay?
That's why you use Linux.
And Linux is well known for being more secure than Windows. Okay. So you want to make sure that if you have several applications running on your system, that they are running independently. They are not starting taking the memory of another one and so on. Or if someone is trying to connect to your computer, they are not going to be able to extract data and run applications. Okay, so security is very important, but again, it has a price. Okay, the more secure system, the slower the system is going to be. Okay, so if you are going to run, if you are using your computer just for you doing video games, is it that important that it's secure? Okay, obviously, if you are running on big military projects, security is really essential. Another thing is that operating system needs to be dealing obviously with networks, and also the operating system, you have to understand, are huge pieces of code. Okay, we are speaking about tens, if not hundreds of millions of lines. Okay, in this operating system. So Windows here is around 80 million. Some very basic Linux systems are around 16 million, and some other Linux systems are in the hundreds. So there are huge pieces of software. Okay, so that's why there are always bugs. That's why you always get patches. Okay, never Linux, never. So it's so big, it's so difficult to maintain them. They've been written for decades. Okay, so they are very complex systems. And obviously, just running your operating system will take a lot of your RAM. Okay. Okay, so after this introduction about operating systems, I would like you to do a bit of experiments. So basically, I want you to go to the dark side. Okay? Because so far, most of you have just used a system based on Windows. Okay? Linux systems are based on Windows as well. Okay? Everything is nice and shiny. You just double click and scroll things. Everything looks nice. But what is behind that? Okay? If you look at some science fiction films, you see this black screen with these lines either in white or in green. Okay? And that's what we want to explore. Okay? So we want to go to the dark side. Okay? We want to look at something like that. Okay? Who has already been there?
Yeah. Or networking.
Yeah. And you have survived?
Yeah.
Well done. So that's where I want you to go for this activity. Okay? So I want you to test two operating systems. One is Windows. So either you have a Windows machine or you go to the library and you will get a Windows machine. And Linux. So either you have a Linux machine or you have a domain which is using a Linux server. And since I asked you all to get a domain with a Linux server, you all have access to a Linux machine. Okay? So that's the two environments that I want you to explore. So if for people who are a bit scared, let's get started with the Windows machine.
So a quick question, can you get a virtual machine on your machine?
A virtual machine on
your Windows machine?
Yeah, why not?
Yeah, they'll do the same job.
Yeah. So if I want to go to the dark side,
Which kind of Linux do you want us to use?
whatever. So if I want to go to the black side on my Windows machine, what should I do? So I'm writing the command cmd, and here I am. Okay? So I can go, for example, on my Edge drive, and at the content of my Edge drive, I can go to my files. I can go into my teaching directory. and I can go to IT Toolbox. And I can see the content of my IT Toolbox directory. Alternatively, if I want to use the user interface, I just go to desktop, teaching, IT Toolbox, and you can see that the information is identical. Okay. However, the advantage of being here is that I have full control. I can do many more things that I couldn't do here. Okay? Let's say that I want to get in a file the list of all the directory which are here. How do you do that? While here, it's very easy. Okay? In one command, I can copy all the content of my directory in a file. If you use the Windows interface, it's not possible. Okay? So using the interface is nice, it makes your life easier, but also it gives you a lot of limitations. Okay? So that's why people who are IT professionals, for certain tasks, they move to the dark side. Okay? It allows them to do many other things. I mean, if you look at people involved in networking, they are there all the time. Okay? Because it's much quicker and you can do many more things. Okay? So it's important for you to be aware of that world and to start using it and be comfortable with it. So now I have a question. How is the dark side on a Mac?
White.
The dark side is white on Mac. Okay, what a surprise. And here is how to access it if you are using a Macintosh computer. Okay? So if you have a Mac or have access to a Mac, feel free to explore that operating system as well. It's based on Linux, so it's not that different. Okay, so thank you very much for your attention.
I think so.
Are you having quick dinner? Like, kind of like, you can begin.